Hi engineers, today we will see how to size cable by taking into consideration voltage drop calculation. We will do this with the example of 3-phase 415-volt low voltage system.
First, let us understand what is voltage drop. When power is transmitted from one location to other, the voltage is dropped due to resistance and reactance of the cable. Look at the below single-line diagram. Some of the locations where voltage can drop while transmitting power from source to feeder are marked in blue. Look at the below example. We have to transmit power from main low voltage panel to pump room. Load at pump room is 40 kilowatts and distance between main low voltage panel and pump room is 100 meters. First we will calculate full load current assuming power factor is 0.8 as shown in the slide. Our full load current will be 69.4 amperes. As our full load current is 69.4 amperes, we will select next higher size cable from manufacturer's cable chart. You can select copper or XLPE cable depending upon project and standards requirement. We will select XLPE cable. Have a look at the polycab cable chart. We will select cable corresponding to 79 amperes, that is 4 core 16 square mm.
After deciding cable size, we have to check derating factors. Cable ampere rating is lowered due to different atmospheric and installation conditions. Derating factors for such conditions are mentioned in cable chart. For our example, let us assume ambient temperature and grouping factor as 0.8 and 0.9. After derating, current rating of cable will be reduced. To calculate this, multiply rated current of selected cable to all considered derating factor. After derating, our cable ampere rating is 56.88 ampere. As our full load current is 63.4 ampere, this cable will not be sufficient to carry entire load current. Therefore we will select next cable size, that is 4 core 25 square mm. After derating, ampere rating of this cable is 77.76 ampere, which is still higher than our full load current. Hence, first criteria for cable selection is satisfied. Our second criteria to select cable size is voltage drop. Acceptable percentage voltage drop criteria may vary from project to project. For our example, let us consider 5% voltage drop is acceptable. Use formula as shown in slide. Value of cable resistance and cable reactance for the selected cable can be found in cable chart. These charts are displayed on the last slides. By using the formula we get voltage drop 3.72%, which is lower than acceptable value of 5%. Hence our second criteria for cable selection is also satisfied. If voltage drop comes greater than our criteria, select higher size cable and again calculate voltage drop till we get acceptable value. Resistance value of cable in ohm per kilometers. Reactance value of cable in ohm per kilometers.